Look up at the night sky. Go ahead. Imagine it. What do you see? You see darkness, don't you? A vast obsidian void, punctuated by a few thousand twinkling points of light. It's beautiful, it's poetic, and most people think it's the most natural thing in the world. The sun goes down, the lights go out, and the sky turns black. Simple. Obvious. Except it isn't simple. It's a catastrophe. If you think you understand why the night sky is dark just because you know the sun is on the other side of the earth, you're in for a very rude awakening. Because according to everything we used to believe about the universe, the old, comfortable, common sense view of a vast, infinite, eternal space, the night sky shouldn't be dark at all. It should be blazing. It should be blindingly white, as bright as the surface of the sun, at every single point, in every single direction, all the time. You think I am joking? I am not. This is what we call Olbers Paradox. And for centuries, it was the ghost in the machine of physics that nobody could exorcise. It's a window into the fundamental nature of reality, and it proves that the world is not what it seems. We prove that, let's look at the logic of the old universe. For a long time, people like Newton imagined the universe was a big, empty box that went on forever. Infinite space. And inside that box, they imagined an infinite number of stars, scattered like dust, shining for an infinite amount of time. It feels right, doesn't it? It feels grand. But if you take that model seriously and you do the math, real math, not government work guessing, the whole thing collapses. Think about it this way. Imagine you're in a very large forest. If the forest is small, you can see between the trees to the meadow beyond. But if the forest is infinite, no matter which direction you look, your line of sight will eventually hit a tree trunk. There are no gaps. The farther away the trees are, the smaller they look, but there are so many more of them in the distance that they eventually fill every single arc second of your vision. You'd be surrounded by a solid wall of wood. Now, replace those trees with stars in an infinite universe. Every time you point your finger at a dark spot in the sky, your finger is actually pointing at a star. It might be 1 trillion light years away, but it's there. And if the universe has been here forever, the light from that star has had plenty of time to reach your eyes. Most people try to wiggle out of this by saying, well, the distant stars are much dimmer. Sure they are. Light follows an inverse square law. If a star is twice as far away, it looks 4 times dimmer. That's basic physics. But here's the trap. As you look further out into space, you aren't just looking at dimmer stars, you're looking at more stars. Imagine the universe as a series of concentric shells, like an onion, with you at the center. The first shell is 1 light year thick. The second shell is also 1 light year thick, but it's twice as far away. The surface area of that second shell is 4 times larger than the first one. So, if stars are scattered evenly, that second shell contains 4 times as many stars. So, do the bookkeeping. The stars in the second shell are 4 times dimmer, but there are 4 times as many of them. The effects cancel out perfectly. The total amount of light hitting your eye from the second shell is exactly the same as the light from the first shell. And the third shell? 9 times more stars, each 9 times dimmer. Same result. Each shell of space, no matter how distant, contributes the exact same amount of brightness to the night sky. If the universe is infinite, you have an infinite number of these shells. You're adding up an infinite series of equal amounts of light. The sum is NT, a nice dark night. The sum is infinity, or, more accurately, the sky should be as bright as the average surface of a star. The whole heavens should be a solid, glowing furnace. We should be fried to a crisp the moment the sun goes down. But we aren't. The sky is dark. That obvious darkness is actually a scream from the universe, telling us that our most basic assumptions about reality are fundamentally wrong. So, what's the mistake? Where did we trip up? The first thing people usually shout is dust. They say there must be clouds of gas and dust out there in the empty space between the stars that block the light. It sounds reasonable. You've seen smoke block a flashlight. You've seen clouds block the sun. But this explanation fails because of a little thing called the second law of thermodynamics, and if you don't understand that, you don't understand how the world works. Remember the towel analogy? If you're wet and you use a dry towel, you get drier, but eventually the towel gets as wet as you are. Energy works the same way. If a cloud of dust is sitting in a universe full of starlight, it's constantly absorbing that energy. It's getting bombarded by photons. And as it absorbs energy, it gets hotter and hotter. If the universe were eternal, that dust would have been sitting there for an infinite amount of time, absorbing an infinite amount of light. Eventually, it would reach a state of thermal equilibrium. It would get so hot that it would start glowing just as brightly as the stars it's trying to hide. You can't hide light with stuff forever because the stuff eventually becomes a source of light itself. So, dust is out. It's a biological hallucination of a solution. The next common sense guess is that the stars are just too far away and their light hasn't reached us yet. Now you're getting warmer. But think about what that actually implies. If the light hasn't reached us yet, it means the stars haven't been shining forever. It means the universe had a beginning. This is the first crack in the Newtonian box. To have a dark night sky, you have to throw away the idea of an eternal universe. You have to accept that there was a first frame in the movie. If the universe is only, say, 8 billion years old, then we can only see light that has had 8 billion years to travel. We are encased in a visible horizon, a bubble of light. Beyond that bubble, the stars might exist, but their light is still on the way. It's like a messenger running toward you from a great distance. If he hasn't had enough time to cover the miles, you don't get the message. But even this isn't enough to fully explain the darkness, because even within that 8 billion year bubble, there are a lot of galaxies, billions of them, each one packed with hundreds of billions of stars. If you do the math on the density of stars in our observable bubble, the sky still feels like it should be more crowded with light than it is. The truth is darker and much more mechanical than just a late start for the stars. The real secret lies in the fact that space itself isn't a static, empty stage. It isn't a box at all. We have to move away from the poetic idea of a river of time and start looking at the flexible geometry of reality. We have to talk about what happens to light when the ruler you're using to measure the universe starts to stretch in our daily lives. We think a mile is a mile and a second is a second. But once you peek behind the curtain, you realize that space and time are woven together into a four-dimensional loaf of bread called space-time. And that loaf is rising. It's expanding. This isn't just a theory. We measured it. We looked at distant galaxies and we saw something absolutely insane. They aren't just sitting there. They're moving away from us. And the farther away they are, the faster they're going. This changes everything about how light travels across the void. Imagine you're playing catch with a friend. If you're both standing still, the ball comes at you at a normal speed. But what if your friend is running away from you as they throw the ball? From your perspective, the ball is going to take longer to reach you, and it's going to have less punch when it arrives. With light, it's even weirder. Light is an oscillation of electromagnetic fields. It has a frequency, a color that our eyes perceive. When a star is moving away from you at a significant fraction of the speed of light, the waves of light it emits get stretched out. The peaks and valleys of the wave get further apart. We call this redshift. If a star moves fast enough, its visible light, the stuff you can see, gets stretched so much that it shifts out of the visible spectrum entirely. It turns into infrared. Then it turns into microwaves. Then radio waves. The light is still there. The energy is still hitting your eyes. But your biological hardware, Those meat-based retinas of yours aren't designed to detect it. You're a disorder detector tuned to a very narrow frequency. So the darkness of the night sky isn't a lack of light. The sky is actually glowing. If you had eyes that could see microwaves, the entire night sky would be a bright, uniform wall of fire, the afterglow of the Big Bang itself. But because the universe is expanding, that light has been stretched and cooled until it became invisible to us. We are living in a universe that is constantly unwinding its own brightness. The darkness is an illusion created by the stretching of space and the finite age of the stars. It's the proof that we don't live in a static, eternal box, but in a dynamic, exploding, and fundamentally weird reality. But that brings us to the biggest question of all. If the light is being stretched, where is it all going? And what happens when we run the movie all the way back to the beginning? If the universe is expanding now, it must have been smaller before, much smaller. And that leads us to a point where the laws of physics themselves start to melt. So, if the light is being stretched, where is it all going? And what happens when we run the movie all the way back to the beginning? This is where the story gets really profound. If the universe is expanding today, it means it was smaller yesterday. If we wind the film back past the Roman Empire, past the first trees, past the formation of the Earth, the galaxies get closer and closer together. The space between them vanishes. Eventually, you hit a point where everything, all the matter in your body, all the stars, you see, every atom in the universe was crushed into a single, tiny, unimaginably hot point. This is the Big Bang. Now people ask, what happened before the Big Bang? And they think they've asked a deep question. But remember what I said about time being a ruler, not a worker. Time is just a way of ordering events inside the universe. Asking what happened before the universe began is like asking what is north of the North Pole. It sounds like a valid sentence, but geometrically it's gibberish. There is no before if the clock hadn't started ticking yet. This start to the tape measure is exactly why the sky is dark. Because the universe has a finite age, about 13. 8 billion years, we can only see stars within a certain distance. It's our observable horizon. Beyond that, there could be an infinite number of stars, but their light simply hasn't had enough time to reach us since the beginning of time. The messenger is still on the road, but there's a second, even more mechanical reason for the darkness, and it comes back to that stretching space. Think about a wave. When you see blue light, you're seeing a wave that's oscillating very fast. Red light oscillates a bit slower. As the universe expands, it literally pulls on the light waves traveling through it. It stretches them out. A wave that started as energetic, visible light billions of years ago has been stretched so much by the expansion of space that its wavelength is now centimeters long. It has shifted from visible light into the microwave part of the spectrum. This isn't a guess. We detected it in 1964. Two guys in New Jersey, Penzias and Wilson, built a massive horn antenna and heard a constant low-level hiss coming from every direction in the sky. They thought it was bird droppings on the antenna. They cleaned it, but the hiss stayed. It was the cosmic microwave background radiation. It was the afterglow of the Big Bang. The sky is actually glowing at every single point. If your eyes could see microwaves, the night would be as bright as a light bulb, but your biological hardware, your retina, only responds to a tiny slice of the electromagnetic spectrum. To your meat-based eyes, that stretched out light looks like nothing. It looks like blackness. So, when you look up at the night, you're seeing two things at once. You're seeing the gap in the stars because the universe isn't old enough to show you everything, and you're seeing the stretch of space that has pushed the earliest light into a frequency you can't perceive. This changes how you see the floor under your feet and the air around you. You realize that solidity is just electromagnetic repulsion and darkness is just light that has been cooled by the growth of the universe itself. Everything you experience is an electromagnetic interaction. When you see a star, you're detecting oscillating fields that traveled for millions of years just to nudge an electron in your eye. When you feel the silence of the night, you're actually standing in the middle of a screaming, expanding explosion that started 13 billion years ago. The fact that we, as tiny biological accidents on a small rock, we could figure this out, that we could use a piece of plastic wrap to understand fundamental forces and the timing of Jupiter's moons to find the speed of light that is the real triumph. We've used tools made of meat and electricity to comprehend the infinite. So, next time you're out at night, don't just see the dark, see the evidence of a beginning. See the stretching of the fabric of reality. You're not just looking at a utility or a convenience. You're looking at a window into the truth. The universe is a carefully balanced dance of energy and geometry. And the darkness isn't a lack of something, it's the proof that the movie had a first frame. We've spent our time today talking about how we measure the world with clocks and rulers. Would you like me to explain how we know what's inside a star without ever leaving our planet?